Okay, welcome guys again. It's Eduraz here. We are still continuing with the question paper, November, paper 1. Now we are entering calculus, of which sometimes becomes a problem for learners to get some marks still because they are already defeated before even calculating answering the questions, but I'm gonna try my best to make everything seem easy as possible. Yeah, let's get to it. So now we're on question 7. First question says that guys, always expect this. Calculus, the first question is always gonna ask you what the first principle of derivative. So it says that we must determine the gradient, the derivative of f of x using the first principle. Everyone's supposed to get marks here. No one's supposed to lose marks, right? So the first principle, guys, is the formula. F of x is f into x plus h minus f of x divided by h. So I forgot the limit as h approaches 0. The first thing that you must do before tackling the first principle, you are always given the function that you must differentiate, right? So the first thing that you must do, in place of x, you must where there is x, you must always add what? H, like that. So f is to x plus h. So in place of next to x, we are going to add what? H. So you are going to have something like x plus h squared plus x plus h again. You see, next to x I added what? H, because that's what I did there. And then now we are going to solve now. So we are going to have x squared plus 2xh plus h squared plus 8 plus h. You see, guys, now I've expanded everything. So this is our f of x plus h. And then I will come to our formula now. F is to x, limit h approaches 0. Now what is our f of x plus h? Is this thing that you've just recently calculated, and then you're gonna put it there, x squared plus 2xh plus h squared plus x plus h, and then minus, and then you put in, please guys, always put brackets around your function, x squared plus x, and then divided by h, because most of you, the error that you make there, for instance, you're just gonna say minus x squared plus x, of which this is totally wrong, because now this x is not multiplied by what? By that negative, of which it was supposed to be. So please, when you write, immediately after you write the negative sign, put brackets there, and then you type in you write in your function. You see, and then I'll continue proceeding. F of x is equals to x squared plus 2xh plus h squared plus x plus h minus x squared minus x divided by h. Oh, I forgot this thing. Limit h approaches 0. Please write that thing all the time, because you're gonna lose marks there. And then f of x is limit h approaches 0, and then now x squared must cancel out, x and x cancel out, and then because I collected like terms, 2xh plus h squared, it's what I'm left with, divided by h. And then guys, what do you see from the numerator? It's the common multiple, which is h. You take out h, and then 2x plus h divided by h, and then these two, they cancel out. Oops. Oh yes. Oh no, I think I made a mistake somewhere. Guys. Wait, let's double check. X squared plus 2xh plus h squared plus x plus h minus 2xh plus h squared divided by h. I think I made a mistake. So let me double check. X squared plus 2xh plus x squared plus 2xh plus h squared plus x plus h minus this one. X squared plus 2xh plus h squared. That and that. 2xh plus h squared divided by h. This one, 2x plus h. And then this 2 cancel out. And then I have 2x. No, I ain't 2x. I'm supposed to 2x plus 1.
2x plus 1.
Yeah. I've not trying to put it here. X squared xh 2xh right here.
Translation is on this.
Then we will limit h x squared plus 2xh plus h squared. Oh yeah. Hey, yeah, no reason. So guys, I'm seeing that I made a mistake, because I cannot get limit h is 0 to xh plus this. No, what I did is I forgot this h, the other h there. You see, I forgot this h. Why did I see the mistake? Because if you differentiate our f of x using now the power rule, the nice thing about using first principle, you can always determine what your final solution, right, before even attempting, just by using power rule. So the power rule is going to be 2x plus 1, right? So I cannot get 2x here. So I clearly forgot what my h there, so I'm supposed to add h. You see that? So let me just scratch it there. Okay, let's just continue. Sorry about that. So f of x, limit h is 0, so it's gonna be 2xh plus h squared plus h divided by h, and then I will take out our common multiple. Lim h approaches 0, h is to 2x, right, plus h, right, plus 1 divided by h, and then those two cancel out, and then you have limit h approaches 0 to x plus h plus 1, and therefore you substitute your 0. Now when you substitute your 0 there, you don't put the limit thing, so it's gonna be 2x plus 0 plus 1, and therefore you have 2x plus 1. So please guys, be aware of those things. Even me there, it got me, but yeah, I was fortunate enough that I've already prevented my solution even before I attempted this, so I can possibly see that, oh, that's how the power rule can help you. You can just predict your answer even before writing it down there. Right, so let's move on to the next question. So the next question now says that determine the derivative if f of x, this one is the easy one, it's the power rule, 3x4 plus 8x. So we're just gonna use the power rule there, which is 10x to exponent 4 minus 12 exponent 3 plus 8. Easy, 2 marks. And then coming to 7.3. 7.3 says that the tangent to g of x, right? This is our g of x, ax cubed plus 3x squared plus bx plus c. So they're saying now the tangent to this function has a minimum gradient at the point. So it has a minimum gradient at the point for, now the question is, for which values of x will g be concave up? So guys, what I want you to know in that is that for type questions like this, again, it's the interval questions, but for cubic function it differs. In order for you to determine the concativity of a cubic function, you must always get what? Your second derivative. Let's say this is our function here. So at the point of inflection, right, it's where the gradient, it's where the graph changes from decreasing to increasing or from increasing to decreasing. That's where our graph changes, right? We call this point the point of inflection. I'm just giving you an example to show you the idea behind this. So now the question asks us here, which values of x will this graph be concaved up? So this means that you must get what? The point of inflection. Now guys, if your second derivative, right, is greater than 0, therefore your graph is what? Concave up. But if your second derivative is less than 0, therefore it is concave down. So let's go ahead and get our second derivative there. So g of x, let's first start with g prime. The first derivative, we're gonna have 3a x squared plus 6x plus b, and then g double prime, so gonna be 6ax plus 6. Now we have this thing. Now to get okay, so now guys, we have our double derivative, and then we're given the x value there, so we're just gonna substitute. So g prime of -1 is 6a is to -1 plus 6, and then 0 is equals to -6a plus 6, and then -6 is equals -6a, -6 over -6, and therefore a is 1. And then now you substitute this one to check now how is our double derivative, positive or negative. It's gonna be 6 plus 6, and then that's gonna give us what? It's gonna be -6. -1 Okay guys, now we're gonna substitute there. Determine now the value of x. So the double prime is equals to 6x plus 6, then you let the derivative be 0. 6x plus 6, -6 is equals to 6 over x, 6 over 6, and then x is -1, right? So for which values of x will the graph be concave up? When x is greater than what? -1. That's where our function will be concaved up. Then now moving to the next question. Question 8. Moving to question 8. Again, I'm gonna sketch the graph. I'm gonna try to make it accurate this time. there's our function, and then we're given point R, which is 0 is to 1. I'm sorry. And then Q, which is 1 is 0, and then P, which is negative 1/3 0, and then this is our 0. Okay, guys, question 8 says that so we're actually given the derivative here, which is mx squared plus nx plus k. This is the derivative of a cubic function. We don't know the cubic function, they just gave us what? The derivative, which is the parabola in this case, because for every cubic function the derivative is always a parabola. So now guys, the first question says that you must determine the values of m, n and k, right, for 6 marks. So guys, what I want you to know, to understand, in calculus, once they give you the sketch of a parabola, what I want you to know is that the x-intercept of the function, the x-intercept of the parabola are always the x values of the turning point of the cubic function. Let me repeat. The x-intercepts of the parabola in calculus are always the x values of the turning point of the cubic function. For instance, let's say you are given a cubic function like this. What I mean is something like this, right? Let's say this is our x-axis here, right? It's not accurate enough. Those x-intercept there of this parabola, they are the x values of the turning point of the parabola. So if you are given the x-intercept of the parabola, therefore that means you have already the x values of the turning points of the cubic function now, right? So now let's get into the question. I wanted to clarify that part. So is f prime is mx plus nx plus k. So now it's gonna be y is equals to a into x minus r1. The basics, guys, of determining the equation of the parabola. When you're given the two roots, you use this formula here, and then you say y is equals to a is to x minus the first root, which will eventually become positive because negative times a negative is going to give you positive, x minus what? 1. And then now you substitute the third point to get what? The a value. So y is equals to 1 is to a is to 0 plus a third is to 0 minus 1. 1 is equals to a, and then it's going to be negative 1 times negative a half. Sorry, you divide by negative a half by negative a half. Therefore a is equals to it's going to be equals to negative 2, sorry, right? And then you write the equation y is equals to negative 2 is to x plus a third is to x minus 1, and then now you just multiply everything now by negative. Distribute the brackets first. You have x squared minus x plus a third x, right, plus a third x, and then minus a third, right? Sorry, it's a third, guys, not a half. I made a mistake, so it's a third, and then you're gonna divide by third, and then it's gonna be 1 divided by third, sorry, which will be negative 3, not negative 2. So you have negative 3, negative 3. and then now you distribute the brackets. X squared negative plus a third, which is negative 2 over 3x minus a third, and then negative 3x squared plus 2x plus 1. So this is the equation of the parabola, and then m is equals to negative 3, n is equals to 2, k is equals to 1. Therefore that's your 6 marks over there. And then the next question now, 8.2. 2.1 says that they have given you the cubic function, which is f of x negative x cubed plus x squared plus x plus 2. They are saying now determine the coordinates of the turning point of f. Now guys, this brings me back to what I said earlier on, that in calculus, whenever you have the x-intercept of the parabola, that also means you have the x values of the turning point of the cubic function. So you're just going to substitute those points. So you're going to first substitute negative a third is equals to negative is to negative a third plus negative a third all squared plus minus a third again plus 2. Then it's going to be 49 over 27, which is approximately 1.41. So the first point of the turning point is negative a third is to 49 over 27, and then we substitute the second, negative 1 is equals to negative is to 1 cubed plus 1 squared plus 1 plus 2. So the coordinates of the turning point are negative a third, 49 over 27, and 1 and 3. And then the following question says that now you must sketch the graph of f, indicate on your graph the coordinates of the turning point, the point, and the x-intercepts of the x's. So we already have the turning point, so now what we need is the y-intercept and the x-intercept. So for the y-intercept, you let x be 0, and then you just substitute the cubed plus 0 squared plus 0 plus 2, which will be f of 0 negative which is 2. So our intercept is 0 and 2, and then our x-intercepts, we let y be 0, so we have negative x cubed plus x squared plus x plus 2, right? So now to find the factor of the cubic function, the easiest way I can show you is using your calculator, né? So what you're going to do, you're going to press mode setup, and then you're going to select option 7 on this calculator, but in most calculators it's going to be option 3. You go to table, and then now you're writing your function negative alpha x cubed plus x squared plus x plus 2. And then how you put your endpoints, it depends where you want to start and finish. So in this case I'm going to use -7 and then end at 7 and then step it's 1. And then now I'm going to check which x value here gives me 0, and then that x value is the one that's going to be the factor there. So 2 does give me 0, so I'm going to use 2. So now I'm going to use the synthetic method of division to get the roots. So 2, I'm going to put 2 there, which is the factor. And then now I'm going to write the coefficients of my variables. So for the first one, it's -1. For the second, it's 1. For the third, it's 1. And then it's 2. And then you always drop the first one as it is. And then it's going to be -1 times 2, which is -2. -2 plus 1, that's -1. -1 times 2, it's -2. -2 plus 1, it's -1. -1 times 2, it's -2. -2 plus 2, that is 0. So for the first part, it's x minus 2 times what? -x squared minus x minus 1 is equals to 0. Therefore x is equals to 2. But for this side, we're going to check our roots using the quadratic formula. Negative is to -b plus -1 squared minus 4 is 2. -1 times -1. It's gonna be undefined, guys, so there are no roots for the second part. So the only root that you have, x-intercept, it's x is equals to 2. And then now we're gonna sketch the function. So our x-intercept, so the first one is -1/3, so it's around here, and -1/3 goes with 49/27. That's 1.81, so it's right here. And then the second one, it's 1/3, which is right across there. And then the second one is the y-intercept, which is 2. And then we have the x-intercept at 1. So our function is like this. And then now 8.3 now 8.3 says that E and W, points E and W are two variable points on the derivative. So our derivative is our parabola, which passes right through here, -1/3 and 1. Right, so this is our parabola here, the one that was given to us, and then this is our function. So we know that the x-intercept of this parabola is actually the x-turning point of the cubic function. And then it says that points E and W are two variables on the derivative, which is they are points on the parabola, and are on the same horizontal line. Okay, H is a tangent at E, and then G is a tangent at W, and then H and G intersect at point D. So H and G, those two tangents intersect at point D, which is A and B. Okay, now the first question says write down the value of A. Okay, so guys, the hint here is that these 2 points, they lie on the same line, the same horizontal line. So if you will construct many horizontal line up until the turning point of the parabola, and then now you construct your tangents, your two tangents, you're gonna get something like this, right? So because these 2 points, they lie on the same line, this means that, because you must remember one thing, that parabolas are symmetrical. Parabolas are symmetrical about the turning point. So meaning the parabola is cut into half. So now if this horizontal line, if these 2 points, they lie on the same horizontal line up until the turning point, therefore this means that they are equidistant from one another. They are equidistant, so they share the same y value throughout up until what? The turning point. So actually what we are looking for here is the coordinates of the turning point of the parabola, because if these 2 points, again, if these 2 points, they lie on the same line, this is E and W, and then it's E and W. So this line, if you're approaching the turning point, it's going to be something like this up until what it reaches what? The turning point. So the turning point is the point that you are looking for, actually. So we're gonna use the formula x equals negative b over 2a, and then it's going to be negative, what is b of our parabola? The b of our parabola was 2, so we're going to say 2 divided by 2 times what was our a of the parabola? So it was negative 3. So you're going to get negative 2 divided by negative 6, which is 1 over 3. So therefore A is equals to that. And then 8.3.2, it says now determine the values of B for which H and G will no longer be tangents to F. Okay, so it says that determine the values of B for which H and G will no longer be tangents to F. So let's first get B. So we have the x turning point, so let's substitute to our parabola to get B. So our parabola, the equation is negative 3x squared plus 2x plus 1. So we just substitute our x variable of the turning point, plus 2 is to 1 over third plus 1. And then negative 3 is to 1 over 3 squared plus 2 is to 1 over 3. We're going to get 4 over 3. So this is actually B. So our points at D are a third and 4 over 3. So now the question says that determine the values of B for which H and G will no longer be tangents to F. So it's 4 over 3. It's 4 over 3 because at this point, right, at this point, at our y-intercept there, at our y-intercept, if we continue going up, those two tangents will move apart, meaning they will not touch each other no more. So hence it's 4/3 there. And then now moving to the last question, question 9, approximation. Given f of x is equals to x squared. Now this question says that determine the minimum distance between the point. So they're giving you the point, I'm gonna call it point P, 10 is to 2. So now what they are actually asking is to determine the distance between this point and f of x. So again, let's sketch our graph. So this is the matter function, so it's it passes exactly at the origin like that. So now this point P is gonna be somewhere here. It's gonna be somewhere here, point P, which is 10 is to 2. So now this is f of x. I'm just gonna give you the illustrative idea of like how this thing actually looks like, but it could be at any point on f. It could be at any point, but I'm just giving you an idea. So they are actually looking for this distance. They're actually looking for this distance between f of x and this point. So now the question is, how can you get this distance between these two? So let's call this point on f, let's call it point A, which is going to be x and y. But guys, at f, we already know what our y is. It's x squared, because its y is equals to x squared. So our point A is actually x and y squared, which you saw, and x squared, because we know that y is equals to x squared. And then point P is 10 and 2. So this kind of question, that's how they actually are. Your y for the function, it's your equation there. So we have f of x is equals to x squared, so that means that is our y. So in place of y, you're going to substitute what? Your function. So now we are going to determine the distance using the distance formula, which will be AP is equals to root x2 minus x1 all squared plus y2 minus y1 all squared. And then AP is equals to 10 minus x plus 2 minus x squared all squared. And then now we're going to square everything to remove the square root. So we have AB squared of x is equals to 10 minus x squared plus 2 minus x squared all squared. And then now we're going to simplify everything. Gonna remove the brackets. We have x AB squared x is equals to it's gonna be 10 minus x plus 2 minus x squared, 2 minus x squared. Then you solve. 10 times 10, 100. 10 minus x, negative 10x. Negative x times 10, negative 10x again, plus x squared, and you do the same. 4, which will be negative 2x squared, negative 2x squared plus x to the 4, and then 100 minus 20x plus x squared plus x4, negative 4x squared plus 4. And then now you derive it. So now we're gonna derive. So the derivative of AB is gonna be AB derivative x squared is equals to, so the derivative of a constant, which is our 100 there, is gonna be 0 minus 20 plus 2x plus 4x cubed minus 8x. Collect your like terms. 4x cubed, 2x plus minus 8x is gonna be minus 6x minus 20, and then that's our derivative. And then now we solve for x, so we equate the derivatives to 0. Therefore x cubed minus 6x minus 20, take out 2 as a common factor, and then you're left with 2x cubed minus 3x minus 10, and then you solve for x. 2x cubed minus 3x minus 10. Again guys, to get your factor you must use your calculator. Go to table, and then you write down your table, your equation. 2x cubed minus 3x minus 10, and then you select your endpoints. Again, I'm gonna use -7 and 7. Step, it's 1. Check for any x value that's gonna give me 0 there. Again, is 2, so I'm gonna take 2 as my factor. So 2, and then I write down the constants of my variables. So for x cubed is 2. For x squared, there is no x squared there, but if the variable is not there, is not existing, you can just use 0 to replace it. So it's gonna be 0 minus 3 minus 10. Therefore you keep the first one as it is. 2 times 2, it's 4. 4 plus 0, it's 4. 4 times 2, it's 8. 8 minus 3, that's it's 5. And then 5 times 2, it's 10. And then you're gonna get 0 there. And then now you write down your formula. So we have x minus 2 is 2x squared plus 4x plus 5 equals to 0. And then there's no solution for the first one, and then x is equals to 2. There's no solution because if you plug it in your quadratic formula there, it's gonna have -4 raised to plus root 4 squared minus 4 is to 2 times 5 divided by 2 is to 2, of which 4 squared is 16, and our 4ac there is going to be -4 times 2 times 5, of which is -40. So 16 minus 40, you're going to get a negative answer, of which now there is no root of a negative. There is no square root of a negative number, so hence it's no solution there. So our x is 2, and then now we look for our distance. So our distance now is going to be AB is equal to 2. You just substitute your x. So it's going to be 10 minus 2 squared, 10 minus 2 all squared plus 2 minus 2 squared all squared. Therefore AB, your distance AP is going to be equals to 10 minus 2 all squared plus 2 minus 2 squared again. It's going to be 2 root 17, which is approximately 8.24 units. That's it guys for today. We finished the paper. All the best tomorrow.